Good afternoon, everyone. Today, because of the time restriction, I will try to give you some insights how the compostable packaging can be positioned in the waste manager together with the bio waste and municipality waste. So, next slide, please, Jima. We can skip this one. Yeah. Okay. So we talk about how we can reduce the amount of the plastic that goes into the landfill. So we talk about the recycling, how we can increase in the recycling rates or so on. But in the current system, the recycling rate is very low and most of the packaging goes to the landfill. So on the next slide, please. And in this sense, the bioplastic, which can be composted, can go to the composting facility alongside the food contaminant, food scraps. It means that you can rinse your food. You can rinse just your packaging out of the food and send it for the recycling. So the compostable packaging can be seen as one of the sustainable approach to divert some plastic waste from the landfills and reduce the plastic waste. So compostable products through the disintegration and the biodegradation process should not leave any impact on the environment. So they should be tested for the toxicology after the composting is completed. Next slide, please. So most of the biodegradation test is based on the European industrial standard and American frame of the composting standard. So the European ones requires the disintegration within the 12 weeks and subsequent biodegradation of the 90% materials completed within the 180 days. While the American ones requires the 60% biodegradation within the 180 days. Again, in the composting condition, in the defined composting condition. So it's obvious that the American ASTM standard is the less stringent threshold compared to the European one. Next one. Okay, please. Thank you. So also I want to highlight that the biodegradability is frequently misused or misinterpreted, where the term is only in the title or main text without any proof or any degradation test being discussed in this study. So in some cases, degradation conditions are often very harsh, very high temperatures, extreme pH values, or not environmentally realistic. So that's why the only way to ensure the standardization of the compostability is to follow the testing protocols developed by the standard bodies. And this will definitely help to misunderstanding and incorrect claims. And the degradation process, that's why needs to really strictly adhere to the standard test protocols. And obviously, standards are not perfect as in their current status, but they will provide a foundation for a structured database. So it will improve the transparency, it will increase the reproducibility of the test results across the different labs, different countries as well. So here, the example of so I want to give an example for PLA, because PLA is commercially, industrially composted products. And if we use the PLA together with the other compostable materials, in the current system, the PLA market share is very less. So as it is in the small quantities, it may compost on the time, but in particular, if you are using the thin coating, like thin PLA lining on the cups or containers, they may disappear. But if the layer is very thick, it will contaminate the compost. So that's why the type of the dimensions, size of the material is very dependent on the composting rate. So even the composting is practiced for a long time. The concept of composting, of the compostable packaging, together with the bio-based, together with the municipal solid waste, is a kind of the new form. So the introduction of the compostable packaging, yeah, may pose some problems if they are not handling in the right way, and it can definitely will lead some heterogeneous composting structure. So therefore, in order to practice composting as a viable waste management system, the composting system must be designed not to form any compostable persistent plastic leftovers, or they need to be, if it happened, they need to be detected, they need to be identified and quantified, and remove the such fractions at the end of the composting process. Thank you, Jima. Just a second. And if you can look at the figure, you can see the biodegradation capacity performance of the several bioplastics, and their plants can be managed, right? Can be happened in the managed and unmanaged environments, and is very clear that, right? If you blend your plastic with the certain type of plastic, they can improve the biodegradation, for example, in home composting. But this is not always the case, because conversely, they can also provide the antagonistic situation, primarily in the freshwater or the soil environments, where the plastic blends exhibit the poor biodegradation compared to the individual compostable plastics. So next slide, please. So that's why, keeping this in mind, we really need to design the compostable plastic, the biodegradable plastic, for the fast composting. So the design of the polymers, right, that are robust and durable for the long shelf life food products in use, that's great, but we need to also consider how we can readily degrade them once they are used, right? And what potential approach could be to address this is modulate the degradation profile of the plastic. And there is actually there is most of the result, I mean, recent results for the composting is working on how we can engineer the biodegradation profile while meeting the requirements for specific food application. That is actually utmost important. So next slide, please, Jima. And we need now is if we come to the microplastic, because if you cannot complete the composting process fully, there is a potential that some microplastic is formed during and at the end of composting process. So the microplastic is defined as a small pieces of plastic, usually measured less than the 5 millimeter, and they are persistent, mobile, and hard to remove from the nature. So if you can see from the figure, I mean, those compostable or biodegradable plastic has a concern for microplastic production forming. And growing of the microplastic actually in the environment, and this includes the sea, soil, and as well as recent studies shows there is the microplastic accumulation or microplastic detection in the food and the beverage as well. So once they are in the environment, microplastic will not biodegrade, and they tend to accumulate unless they are specifically designed to be biodegraded in the open environment, which is not seen feasible in the current system. So next slide, please. And if we look at how the EU legislation contributes to remove or to reduce the microplastic. So we may say there is two types of microplastic. One is intentionally added, one is non-intentionally added. So the EU legislation actually has taken the major step to protect the environment by adopting some measures that limits the microplastic, intentionally added microplastic use in the products. So these products, what are those products? So the microplastic can intentionally added as a granular infill material on the artificial sport surfaces, and cosmetics. Actually, most of the cosmetics has the microplastic added for multiple purposes, for exfoliation, for the better surface smoothness, so on, and also detergents, fertilizers, plant production products, toys, medicine, so all, just I name few. So they also have the microplastic intentionally added, right? And the EU legislation will prevent the sale of microplastic, and their products to add the microplastic have been added on purpose, and they will limit their release of the microplastic when it is used. So next slide, please, Jima. And what about the non-intentional added microplastic? So we can classify these non-intentionally added micro as a part of the uncompleted composting. As mentioned earlier, if the composting is not fully completed, you will have the unintentional microplastic accumulation, and they will release into the media, they will release in the compost. Then the compost will be a kind of pathway to reach the microplastic to the food, to the animals, to environment in general. So there is no EU law in place currently applying the microplastic in a comprehensive manner. So next slide, please, Jima. Thank you. If we talk about how we can detect them, right? So there is different, you need to detect them, you need to identify them, and you need to quantify them. So, and if you want to detect, identify, and quantify, you need to use the combined method rather than rely on the some microscopic methods or some spectroscopic methods. So, for example, if you really want to combine, if you can combine the two methods, which could be FDAR, which is spectroscopic method, with the TGA, so applying this thermoanalytic method, you can detect, identify, and also quantify your microplastic, which is not disclosed in the literature yet. So there is many ways to go to detect and understanding the quantification. And another issue challenging now when we look at the literature, some of the results are presented as gram of the microplastic per total kilogram, and some of them as a number of the microplastic fractions per kilogram. This will really lead to inconsistency in evaluation, assessing of the microplastic. So, in summary, we don't have any standard and holistic approach to assess, evaluate, and validate the microplastic in the compost, or the likewise in also other food system as well. So thank you very much. I came to my end of my presentation. So I will be happy to take any question if you have.